Dear students, welcome to the lecture series of Materials in Focus. Dear students, today we will discuss about the Dalton atomic model. Dalton was a British chemist, and in the start of 19th century he gave his atomic model. Since you know that according to Democritus, matter composed of the smallest particle known as an atom. Here, Dalton basically supported the idea of Democritus, and with his scientific data, he basically confirmed the existence of an atom. Dalton combined the law of conservation of mass and the law of multi-proportion. And on the basis of these two laws, Dalton proposed that there must be fundamental, basic, smallest particle atom which will combine and make a material. Now, dear student, what do you think how Dalton did? How Dalton gave the idea of the smallest particle and as an atom? So he combined the law of conservation of mass and the law of multi-proportion. What do you think? What is the law of conservation of mass? Basically, law of conservation of mass states that the mass of initial product before the chemical reaction is equal to the mass of the final product after the chemical reaction. Consider the example of water molecule. The general formula for water is H2O. Since you know that every element is basically exists in the form of molecule. So when the one molecule of oxygen combine with the two molecules of hydrogen, they form two molecules of water. So as you know that the atomic mass of oxygen is 16. So when two molecules of oxygen combines, their net atomic mass is 32. Similarly, when the atomic mass of hydrogen is 1 and the two molecule of hydrogen, the mass of the two molecule of hydrogen atom will be 4. So initially the mass of oxygen molecule and the hydrogen molecule, when combined, they make 36, and the total mass after forming the two molecules of water will be 36. So this is called the conservation of mass. Initial mass of oxygen and hydrogen when they combine is 36, is equal to the final mass when they form a water molecule, and it is 36 grams. Consider another example of hydrogen peroxide. The general formula for hydrogen peroxide is H2O2. So basically the one molecule of oxygen is basically combining with the one molecule of oxygen in hydrogen peroxide, and they are forming H2O2. So initially the mass of oxygen is 32 before the reaction. The mass of oxygen molecule is 32. Similarly, the mass of hydrogen molecule is 2. So the net mass of hydrogen molecule and the oxygen molecule is 34. And after the combining, they form hydrogen peroxide, and their total mass is 34. So the mass of hydrogen and oxygen at the start of reaction is basically equal to the mass of the final product, which is hydrogen peroxide, and it is 34. This is basically a conservation of mass. Now if we take the ratios of both of these, If we consider the hydrogen H2O, the water, the ratio of H2O is basically 32 gram by 4 gram, and it is equal to 8. So the ratio is basically a whole number. 8 is a whole number. Similarly, if we take the ratio of H2O2, basically it is 34 gram divided by 2 gram, and it is 17. So this ratio is also whole number. What this mean? This means that neither oxygen, neither hydrogen is basically in the form of half. They are basically combined as a whole, and this indicates that there is the smallest particle which is in the form of whole number, and that particle is an atom. So by the combining of the law of conservation of mass and law of multi-proportion, Dalton confirmed that the matter must be made of indivisibly smallest particles, and these particles are known as the atoms. So basically, he is validating the idea of Democritus that there is a smallest particle, and that smallest particle is undivisible, uncountable atomos or atom. Furthermore, Dalton proposed that in different materials, atoms are arranged in a different ways, like this. And when these atoms arranged in different ways, they form compound. For viewing more informative videos, watch and subscribe our channel Materials in Focus.